the black hole in space, where the gravity pulls so much that even light is unable to escape. Look at this. This is an image of a real black hole. The name of this black hole is Sagittarius A, and it is very interesting to know that it is present at the center of our Milky Way galaxy. Whenever I think about black holes, a question comes in my mind. How would the black hole have finally formed? So let us know how the black hole was formed. So I am Shashank Santosh Nawalkar from SSN Astronomy, and let's start today's video titled The Mysterious Origins of Black Holes. For the formation of black holes, we should know the formation of stars. So first of all, let us quickly look at the formation of stars. Basically, the stars are formed in the clouds of dust and gas, that is, in nebulas. Due to gravity, the clumps are formed in these clouds of dust and gas. And in these clumps, the stars are formed through the process of nuclear fusion. A nuclear fusion is the process by which atomic nuclei combine to form a heavier nucleus. So, this was the basic formation of a star. So let us now go over the formation of black holes. A black hole is an object whose density and mass are very high. It has a very high gravitational pull. The point of no returns, called the event horizon, marks the boundary of black hole. Once something crosses the event horizon, it is trapped by the black hole's gravity. If you compress something so much that light can get so close that it can't escape the gravity, you got a black hole. Here, compressing mass doesn't make more gravity. It just means that you can get closer to the center of the mass and so can feel more of that of same gravity. It simply means that compressing mass does not make more gravity, but gravitational force is greater because so much matter is in a smaller volume. So from here, we have understood one thing, that star get compressed and turn into black hole. That's fine, but ultimately, how are stars compressed? Can all stars compressed and become black hole? The answer to these questions are very interesting. Let's see it. Basically, stars are able to maintain their shapes by the gravity and nuclear fusion. There is a large amount of hydrogen present in the star, and it acts like a fuel. Through the process of nuclear fusion, hydrogen gets converted into helium, helium into carbon, and carbon into other elements. The heat released in this reaction, which is like a controlled hydrogen bomb, is what makes the star shine. This additional heat also increases the pressure of gas until it is sufficient to balance the gravitational attraction. And this is how the stars maintain their shape. So let's try to understand it through a very good example that I took from the book The Theory of Everything, written by Professor Stephen Hawking. So let's consider a balloon where there is a balance between the pressure of the air inside which is trying to make a balloon expand, and the tension in the rubber, which is trying to make a balloon smaller. The star will remain stable like this for a long time, with the heat from the nuclear reaction balancing the gravitational attraction. Eventually, however, a star runs out of its hydrogen and other nuclear fuels, and paradoxically, the more fuel a star starts off with, the sooner it runs out. This is because the more massive the star is, the hotter it needs to be to balance its gravitational attraction. And the hotter it is, the faster it will use up its fuel. When the stars run out of fuel, at this time gravity also plays its role. Due to no fuel, the stars will start to cool off and so to contract due to gravity. This contraction causes gravitational force of a star to be increased a lot, because of which stars explode in a very dangerous way. We call this explosion as supernova explosion, and it is from this supernova explosion that the black holes are formed. So what you are seeing on your screen right now can be understood as the diagram of a black hole. The red dot that you can see in this diagram, which is present in the center, we call it as singularity. It is a most massive and dense point. And this part is what we call the event horizon. So this was all about the formation of black holes. So let us now move on to the question that I had asked earlier. That question was, can all stars compress and become black hole? The answer to this question is no. Not all stars can become a black hole. To understand well that not all stars can become black hole, we have to know the Chandrasekhar limit. Basically, Indian-born astrophysicist Subramaniam Chandrasekhar discovered the Chandrasekhar limit in 1930. He calculated that a cold star of more than about 1.5 times the mass of Sun would not be able to support itself against its own gravity. This mass is now known as the Chandrasekhar limit. So now, a star below the Chandrasekhar limit becomes a stable white dwarf star, and if the star's mass is greater than the Chandrasekhar limit, it will explode in a supernova and create either a neutron star or a black hole. But how to know that which star will become a neutron star and which will become a black hole? So the fate of star depends on its mass. The stars with a mass between 1.4 to 3 times that of the Sun will form a neutron star, and the stars with a mass above the 3 times that of the Sun will typically form a black hole after this supernova explosion. So this was all about the black holes. I hope you found this video informative. So please like, share and subscribe to the channel. Thank you for watching the video.